Hi everyone, welcome to this electrifying class on electricity. So guys, can you hear me? Good evening, welcome everyone. And we are going to be looking at electricity in this class. So I'm going to make the concepts really easy for you, and I'm sure you'll find the concepts of electricity really easy after watching this class. And guys, I'd also like to let you know that we have this website, manochaacademy.com. So do check it out. We have these courses on physics and chemistry for CBSE class 9 and 10. So guys, do check out our courses, and we've got big discounts going on right now. And these CBSE courses will really help you in your preparation. So guys, are you ready and excited for this class? So let's go ahead and start. So can you imagine what life would be without electricity? We know that we are dependent on electricity all the time, right? Because all our bulbs, the iron, the computer, the trains, the washing machine, everything runs on electricity. So imagine our life without electricity. And actually we experienced that in Calcutta, right? There was this cyclone Amphan, and it was a really bad cyclone which was very devastating, and a lot of the electricity in West Bengal and the neighboring state Orissa was cut off, and a lot of people's lives were affected during this time. So without electricity, you know, it's a really difficult life these days because everything runs on electricity. And so before we start on what exactly is electricity, let's take a look at what are the type of electric charges. So guys, what are the type of electric charges? You can divide the charges into positive and negative. So electric charges can be divided into positive and negative charge, right? And how do you get positive charge? You guys must be knowing this, that if you take a glass rod, right? So let's say I have a glass rod here. Okay, and if it's rubbed on a silk cloth, so glass rod rubbed on a silk cloth, you know, the glass rod is going to get positively charged, right guys? The glass rod will get a positive charge. And if you take a ebonite rod, okay, so if we have an ebonite rod, so if you take a ebonite rod and you rub it on wool, so guys, what is going to be the charge on the ebonite rod? And some of you are asking my name. Okay, my name is Sandeep Manocha, and so do check out our website and our channel. Website is manochaacademy.com and our channel is Manocha Academy. Okay, so right, and thanks guys, and do share it out with your friends. And guys, if you haven't hit the like button, please hit the like button right now. So come on, I want all of you to try. So when an ebonite rod is rubbed on wool, very good, it gets a negative charge. Okay, so charges can be classified as positive and negative, and these have been decided by the scientists. Okay, so some scientists, so the convention has been decided by the scientists, right? This team of scientists said, okay, when glass rod is rubbed on silk, we'll call it positively charged. So this type of charge will be known as positive, right? This example. And when the ebonite rod is rubbed on wool, the ebonite rod gets a negative charge. And the wool, of course, gets a opposite charge, right? The positive charge. Same way with the glass rod gets a positive, the silk cloth gets a negative charge. Okay, clear guys? So these are the types of charges, positive and negative. And all of you must be knowing, right, that opposite charges attract each other. Like you know about the North Pole and South Pole, right? So North Pole and South Pole of a magnet, you know, they attract each other. So you know that opposite charges, a positive charge attracts a negative charge with a force, right? And like charges, right? Like charges means similar charges. So if you have two positively charged bodies, what will happen guys? They will be repelling each other, right guys? So two positively charged will be repelling each other. And what about two negatively charged bodies? They will also repel each other with a force. Okay, so as you can see from the picture here, so like charges, they repel, and opposite charges, they attract each other, right? So is that simple? right? So these are the basics of charges. I think all of you know about these simple concepts, or if you don't know, don't worry. We're going to discuss a lot of things about electricity today. Okay, it's going to be an electrifying class. And what is the SI unit of charge? So guys, what do you think? What is the SI unit of electric charge? Is it ampere? Is it volts? Is it coulomb? Or is it watt? What do you guys think? And I want all of you to try in the chat here. I'm taking a look at the chat. So I want all of you to try. And doesn't matter if your answer is right or wrong. Okay, this is not a test. We want everybody to get to attempt the questions. Okay. Okay, excellent. I see Vinay, Manu, they're saying coulomb. Okay, Himanshu says coulomb. Excellent, guys. Please remember the SI unit of electric charge. The right answer is coulomb. And we need to remember this because it's not that we use coulomb in our everyday lives, right? It's not often used. Okay, so coulomb is the SI unit of electric charge. Clear, guys? And the spelling, please note the spelling. Okay, so it's C-O-U-L-O-M-B. So I remember the word. You can say the word as coulomb. Coulomb. Okay, so sounds cool, right, guys? But it's not C-O-O-L as cool. It's coulomb. So please note the spelling. And what is the symbol for coulomb? It's denoted with a capital C. Okay, so coulomb, right? So for example, we say this body has a charge of, if it's a positively charged body, we can say this has a charge of +5 coulomb, capital C, right? Let's say this is a negatively charged body. It has a charge of -2 coulomb. Okay, where capital C stands for coulomb. Excellent, guys. Very good. And you must be knowing this, right? That a lot of you have studied in chemistry, right, or physics, that an atom is made up of subatomic particles, right? You've heard of these subatomic particles: protons, electrons, and neutrons. Okay, so guys, can you tell me what is the charge of one proton? So let's start with the proton first. What is the charge of a proton? Come on, I want all of you to try. Come on, guys. Excellent, excellent. I see Aditya Prakash, very good. A lot of you, yes, proton, guys. So let's look in this picture here. You know, proton are these positively charged particles. So these red ones are the protons here, okay? And the gray ones are the electrons, the negatively charged particles. And you know what is the charge of a neutron? Neutron has no charge, right? So roughly speaking, we can write charge of a proton is +1 unit, right? Charge of an electron is -1 unit, and charge of a neutron is 0. Basically, we say it's neutral. Okay, and this unit is because it's a very small amount of charge, so we just say +1 unit. But if we want to write it in SI units, it's a very tiny charge. And remember, we said what is the SI unit of charge? We just talked about it, coulomb. So how much is the charge of a proton in 1 coulomb? In coulombs, you need to remember that. So that's going to be equal to +1.6 into 10 to the power -19 coulombs. Okay, guys, so +1.6 into 10 to the power -19. Excellent, excellent. And electron is exactly same as the proton except with the negative sign. Okay, so it's going to be -1.6 into 10 to the power -19 coulomb. Okay, and what is the charge of a neutron? Neutron has no charge. It's just 0, right? So we can say it's 0 coulombs. Clear, guys? Excellent. So please remember this very important value, 1.6 into 10 to the power -19, right? -19. It's a very, very small amount of charge. Okay, very good. Awesome. And you know that these the atom is made up of these subatomic particles, which are charged particles, right? Because we are talking about electric charges. So we have to note that protons, electrons are the charged particles in an atom. But guys, what is the charge of the atom? The atom itself has 0 charge. It's neutral because the protons and electrons, they cancel each other. Okay, the charges of a proton and electron will cancel each other. So the atom is neutrally charged. Okay, it has no charge. Excellent, guys. And guys, if you haven't hit the like button, please hit the like button right now and do share it out with your friends. Okay, so let's move on to, so we talked about electric charges, right? And even electricity can be classified into 2 types. So let's talk about what are the two types. So you must have heard this famous experiment that if you take a comb, right? So can you see in this picture there's a comb here? So if you take this comb and you rub it on dry hair, right? So you can see I'm taking the plastic comb here and rubbing it on my hair, right? And it has to be dry hair, not wet, okay? Then you know what happens, do you know? Very good, guys. Excellent. Some of you are writing that. So you know that the comb will develop a charge. The comb actually becomes negatively charged, okay? And the hair becomes positively charged. Now, why is that? Because electrons, very important concept, guys, because electrons move from the hair to the comb, okay? So there is a transfer of electrons, okay? So there is a transfer of electrons. So just like the glass rod gets positively charged because the electrons get transferred from the glass rod to the silk cloth, similar, and the ebonite wool. So similarly here, guys, the electrons will get transferred from the hair to the comb. And excellent, I see Kirit, Ayush, very good, Srinivas, Abhishek, they are saying this type of electricity, superb, guys, is known as static electricity, okay? Why the word static? Because there is just a transfer, okay? There is no motion or movement. There is a movement of charge, but no continuous movement, just a single time transfer. And this is called static electricity, okay? So this is an example of static electricity. This is one example. And guys, you know the lightning, right? So Calcutta, we had a lot of lightning, thunder. We are having a lot of bad weather this week, and next week also is predicted. So a lot of lightning is happening, and lightning is also due to static electricity, okay? So these are examples of static electricity. Now there's another type of electricity which we are using all the time, right? That runs our computers, lights, fans. So what is that type of electricity? So come on, guys. Very good, very good. I see Sonal has the right answer. Excellent. That's called current electricity, right? So one is static electricity, and you can also have current electricity, right, guys? So current electricity is an example. Can you see this bulb is glowing in the picture here? So the bulb glows, right? And that is an example of current electricity because current is flowing in the wires. So we have current flowing in the wires, or we should say charges are moving, okay? So the important thing is that there are some charge particles, because you know electricity is about charges, right? So there is charge moving continuously in the wire, okay? So there is continuously some motion of charge happening in these wires, which is causing the bulb to glow. And same with your computer, right? So these are all running on current electricity, right? You've heard the word current, electric current. So this falls in this category. And what is the important thing? Continuous motion, continuous movement of charges, okay? So continuous movement of charges, and that is current electricity. Excellent, right? So some of you are asking which class this is for. This is for class 9, 10. Some of you who are in 7, 8 also, it will be helpful for you, right? So anybody who wants to learn the basics of electricity and get it crystal clear, this class is for you then, all right? So this part is clear. Let's continue, right? So, and our focus in this class is actually going to be on current electricity, right? So let me mark that here. So this will be the focus of our class. It's going to be on current electricity, right? We won't be focused too much on static electricity. So we talked about that transfer of charge, the glass rod and silk cloth, the ebonite rod and wool, and the comb and hair example, they are the transfer of electrons, okay? But this continuous motion which causes current to flow through is what we're going to talk about. So let's look at current electricity, right? So we said what is moving in this. So can you see this setup? Can you see the bulb is glowing here? So clearly current is flowing, right? The bulb tells us, because the bulb glows, so definitely there is current electricity present in this circuit, right? So in this setup. And what is moving in the wires, right? So we know that, guys, charges are moving, right? But can you tell me exactly what charges are moving? So is it protons, electrons? It can't be neutrons, right? Because neutrons don't have any charge. So what do you guys think? Excellent. Excellent, guys. I see science is life, right? Rokia, Shreyash, very good. You guys have the right answer, absolutely correct. What is moving in the wires, guys? Electrons. Electrons, the tiny charged particles, right? And as we learned, electrons are negatively charged particles. So negatively charged particles. And it is these negatively charged particles that are moving in the wire. Clear, guys? So the negatively charged particles moving in the wire is causing current, electricity. Okay, so they are flowing in these wires. So let's write that down, guys. So it's the electrons that are electrons, which we symbolize with this E symbol. Electrons are flowing, or we say moving in the wires, and that is causing the bulb to glow. Superb, absolutely right. You guys rock. Okay, and so we can talk about this movement of electric charges, right? That is known as electric current, right? So what is electric current? We can define it as the flow, right? The flow of electric charges, right? And here we know the electric charge that is moving is electrons. It could be protons also in some other situation, but usually, you know, the electrons move, right? Because the electrons are the light particles, right? And they are not in the nucleus of the atom. The protons are tightly bound in the nucleus of the atom, and so the protons cannot move well. The electrons can easily move. Clear, guys? So the electric current is due to the flow of, is defined as the flow of electric charges. Okay, excellent. And how do we define electric current, right? So electric current is also, how do we give it a numerical value? It is the rate of flow. So current can be defined as the rate of flow of electric charge. Okay, and the current symbol is basically rate of flow of electric charge. The current symbol is I, right? I don't know why they use I for current. I'll have to look that up, but the scientists have using the symbol I, okay, for current, because C is used for coulombs, right? So they can't use C again, right? So I, right, is equal to, and Q is used for charge, guys. So the symbol of charge is Q. So let's write that down. So I is equal to Q divided by time. Okay, so I is equal to Q divided by time, where Q is basically charge, because it's rate of flow of charge, and you know rate means divided by time. So this is basically your formula of current, right, guys? So let's say, for example, let's say we have let's say 10 coulomb of charge. Okay, let's say we have 10 coulomb of charge flowing in 2 seconds. Okay, so 10 coulomb of charge flowing in 2 seconds. So how much current is that? It's going to be 10 by 2. So that's going to be 5 coulomb per second, right, guys? It's going to be 5 coulomb per second. Now, what is the unit of coulomb here? Of electric current. So it's coulomb per second. And excellent, guys. You guys already have the answer this question, right? So what is the unit of current? It's basically ampere, right? So you must have heard of this in your daily lives, right? 5 ampere current, 10 ampere. So this is ampere is basically nothing but coulomb per second, right? So coulomb per second has the symbol of ampere. So we can write the current flowing here is 5 ampere. Very simple formula. You just divide the charge flowing divided by the time. So 10 coulomb by 2 seconds, and that's going to be 5 ampere. Excellent, guys. Clear? So current, electric current, remember that it is the rate of flow of charge, and the symbol of electric current, as we discussed, is I. So there are a lot of symbols and terms to know in electricity, and we can say current is flowing in these wires. And as we discussed, what is flowing? The electrons. Superb. Now question is, who is moving the electric charges, right? So we said that the electrons are moving in the wire. So I have this question, guys. So in this circuit, right? So in this setup of the, you can see the cells are there, the switch, the wires, the bulb, right? So can you tell me who is moving the electric charges? Or in other words, who is moving the electrons, right? So what do you think? Is it the switch, the cells, the bulb, the wires? Come on, I want all of you to try, and I want all of you participating here to also hit the like button and share it out with your friends, so that we can have more people on these live classes. So come on, guys. Okay, very good. Some are saying cells, some are saying wires. So come on, what do you think it is? It's excellent to see the response of everybody trying here. Very good, guys, very good. So electrons are flowing, but my question is, who is moving, right? Who is pushing the electrons? Okay, so you know it can't be the switch, right? Because the switch can go on and off. So this answer is definitely not the right answer, okay? And it can't be the bulb also, right? Because you could have a fan, you could have a different electrical appliance. So you just don't need a bulb, right? So that is definitely wrong. Wires. So definitely we said electrons are flowing in the wires, right? So if we draw these electrons, right? So let's say there are these electrons in the wires. Okay, so I'm drawing these electrons with the yellow dots here, right? Can you see, right? So electrons are flowing in the wires, right? There's a continuous motion, right? And we'll talk about the direction later, right? So let's say the electrons are flowing this way in the wires, right? So now who is causing it? Definitely the wire is needed, but you know that a wire is not sufficient, right? Because what do you need? Very good, guys. You also need a cell. So till you connect the cell or the battery, what we call, you will not have electric current. So very, very important concept, guys. It is the cells, or what we call as the collection of cells here. Can you see it's known as the battery here? So that is needed for the electric charges to move, or the electric current. And what is the general term used for this? So very important. So what is cells or batteries, or you know the electrical supply that you're getting at home? So what is that known as? So this the general term is, this is called as electric potential. Very important. So the term is electric potential, also known as voltage, or also known as electric potential difference. There are many terms, right? So electric potential difference, right, guys? Or simply potential difference. Okay, so, or let me write all those terms here for you, right? So these all mean the same thing. Okay, guys? So electric potential, voltage, electric potential difference, or potential difference. So very important for you to know that cell supplies this electric potential, right? So cell is providing this thing, okay? And it is the cell which is driving the electric current. So if, very important sentence, if there is no electric potential difference, or there's no electric potential, there will be no current. Okay, so if the electric potential goes in my house right now, I hope it doesn't, this live class will stop, because there will be no electricity, my computer will not run, I will not be able to, my camera won't run, nothing will run, right, in the room. So very important, electric potential or electric voltage is needed for the for moving the electric charge, right, or for the flow of electric current. Very important concept. Now what is this guy? So what is electric potential? Let's understand it. So guys, do you know what is electric potential? So you must have heard of this term, right? Potential energy, or potential, right? So you need a potential energy, or potential, right, at a height, right? So you've heard of this term. So let's write it here, right? You've heard of this term, potential energy. So this term sounds similar, right? And what is potential energy? Energy at a height, right? You've seen this. So can you see that we say that this ball has high potential energy when it's at a height, right? So here it's moving from high potential, or high potential energy, right, to low potential energy, or low potential. Let's write it as potential here. So I'll erase this and write, okay. So you know, for the motion of this ball, right, you need a high potential to low potential. So what are we having here, guys? Very important concept. So can you see there is a potential difference needed? So potential difference is needed for the motion of the ball. So potential difference is needed for the motion. Similarly, you know that for water to flow, you need a slope, you need a potential difference, right? Water has to flow from high potential energy to low potential energy, high potential to low potential, okay? So that is why we have the term potential, right? And similarly here, guys, okay, it's similar thing here, that electric potential is what we are having in electricity also, right? So electric potential is needed for the flow of charge. So you can think this, what is this electric potential exactly? You can think it like electric potential is basically like electric pressure, right? There's some pressure needed for the electrons, let me draw the electrons, I think in white, it will look better here. For the electrons to move, okay, so some electric potential is needed, right, to move these electrons. It's like a motor. You can think a motor is needed to move the water, right, to make the water flow, or a height or a slope is needed. Similarly, electric potential is like an electric pressure that is needed to make the electrons move for the flow of charge, right? And if you don't have that, obviously that bulb will not glow, you will not have any charge. So you know, when the cells, the battery run out, the electric potential will become zero, the bulb will stop glowing. Clear? Very, very important thing for all of you to know. Electric potential is like an electric pressure. Just like you know that when the exams are near, we are under pressure to study, right? We study with the exam pressure, or if we have a deadline to meet, some homework to do, we study because of that pressure. That pressure drives us to finish off our syllabus, right? Similarly, it is this electric potential, or what is known as voltage. Same thing, guys. Electric potential or voltage, it is like this electric pressure pushing the electrons, because if you don't push them, they are just going to move randomly in the wire. There's going to be no current. Clear? Please clear your concept. This is very, very important. Excellent. And now, how is electric potential defined? It can be defined as the, so electric potential or electric potential difference, right? We say between 2 points, right? So let's say if you consider the electric potential difference between 2 points, it is defined as the work done. So let me explain that to you guys. So it is defined as the work done per unit charge. So what does that mean? So the formula is electric potential between 2 points. Let's write that here, between 2 points, okay, is defined as the work done by charge. So 2 points means any 2 points you're considering in the circuit. Let's say this point here, point A and point B, right? So whatever 2 points you're considering, or the ends of the battery, right? The terminals of the cell, right? So it is defined as the work done by the charge, right? So let's take an example. Let's say the battery here, the cells are doing, let's say 10 joules of work, okay? So they're doing 10 joules of work to move 5 coulombs of charge, okay? So the work done is 10 joules divided by 5 coulombs, okay? So what is the potential difference? Come on, can you guys calculate? So what is the potential difference going to turn out to be? Work done per unit charge means work done divided by charge. So who can tell me what will be the electric potential here based on these numbers? Excellent. I see Narendra has the right answer. Sridhar, Shaurya, come on guys, all of you think. So it's going to be 10 by 5, simple. 2 joule per coulomb, right? Let me write that in yellow here. So it's going to be 2 joules per coulomb, and this joules per coulomb is known as volts, okay, because the potential difference, so here the electric potential is going to be 2 volts, okay, so electric potential is equal to 2 volts here, because joule per coulomb, the SI unit is basically volts. Clear? So that is the SI unit of electric potential, right? Joules per coulomb, right? And we do we have 10 joules per 5 coulomb. And who's doing the work, guys? The work is done by the cells here. They are doing the work, right? Is that clear? Okay, so that is the important thing here, that electric potential is the work done by these cells, right? So who's doing the work? These cells. Very important for you to remember. And as we said, what is the unit of electric potential? We just discussed, guys. So can you tell me what is the SI unit? So unit means obviously we are talking about the SI unit here. What is the SI unit of electric potential? Volt. Very good, very good. So the SI unit is going to be volt, and the symbol is basically capital V. Okay. So guys, please remember that. And potential difference, let's again write the formula clearly. Electric potential is basically work done, right? So you have work done by charge, per unit charge. Very important formula, okay? And that can also, you can write that down as W by Q. Okay guys, so electric potential is W by Q, and the symbol for potential also is V. So the symbol for electric potential is also V, just like the symbol of the SI unit is V. For volts is V. Okay, so V is equal to W by Q. Clear, guys? Work done per unit charge. And who's doing the work? The cells, the battery. Excellent. Clear? So now one very interesting question for you guys. So do you guys know what is the potential difference of a AA cell? Okay. So this the cells that you use, you know, these cells are known as AA cell, right? Okay. And please understand what is the difference between cell and battery. Battery is a collection of two or more cells, right? So typically when you have one like this, we call it cell, right? Battery is typically two or more cells. So who can tell me what is the potential difference, and what are we measuring the potential difference between these 2 points, between the positive terminal and the negative terminal of the battery? Potential difference means it is measured between 2 points. Okay. So, and potential difference can be measured using a voltmeter. Okay. So just like current, I think I forgot to mention current, you guys know, can be measured with an ammeter. Potential difference can be measured using a voltmeter. So very good. I'm seeing different answers here. So potential difference can be measured using a voltmeter. It's an instrument, right? So if we connected a voltmeter to this cell, right, how much electric potential it would be, right? And guys, if you have a cell at home, please pick up and check, right? I don't think you can read it here. It's really written in small. The value is actually given here in the picture. The correct answer is 1.5 volts. Please check. In even a AAA cell, the thin cells, the AA, AAA, they are all 1.5 volts each typically, right? So absolutely very good. Some of you got it right. So the electric potential or the voltage that this cell can supply is 1.5 volts. Awesome. Correct answer. Fantastic, guys. So please remember, and I encourage you to pick up a cell at your home and do check the value. You'll see it's clearly written there, 1.5 volts. And remember, volt is the unit of electric potential. The guy who's doing the work, the guy who's pushing the electrons in the circuit, the guy who's responsible for the flow of electric charge. Awesome, guys. Now let's talk about this concept of electric circuit. So we talked about electric charges, we talked about electric potential. Now let's also talk about electric circuit, guys. Okay, so here you can see that this is the actual circuit, right? So this is the real circuit, where you can see I've connected this cell, right? So we have the cell here, we have the can you see, guys? So here we have the collection of cells. So there are two cells here which form the battery. So two cells forming the battery. And guys, can you see the switch there? This is the switch, okay, which you can, you have to switch it on to make the bulb glow. That's why it's off right now, because the switch is in the off position. These are of course the wires, right? And here you have the small bulb, right, guys? So this is the real circuit. And here is what we draw. This is known as the circuit diagram. I'm sure those of you who are doing electricity, I know a lot of you are doing it because that's why you requested for this electricity class. So here we are discussing the awesome topic of electricity, and this is a circuit diagram, which is a simplified diagram, right? So where we use circuit symbols. So you can find this in the book, and you'll see that this is the symbol used for batteries, where each one is the individual cell, right? So this is a cell. So can you see there are two cells drawn here in this battery, right? So there are two cells and they're marked with a plus minus, right? From that shows the potential difference, right? So plus is the higher potential difference, positive potential difference, and minus is the lower potential difference. And all these lines here that you see, these are the wires, right? And wires, they're good conductors of electricity because the electrons can easily flow in the wire. And then here, what you can see here, this looks like a gate, right? So this looks like a gate. This is our switch. So when the gate is in the open position, the switch is off. And when you close the gate, the switch is going to be on. Okay. So guys, this is known as so when the switch is off, so very important thing, when the switch is off, it is called an open circuit. Right, guys? So switch off is called open. And when the switch is on, okay, so when we are talking about the switch on off, it's known as a closed circuit, right? Because the gate is closed. So it's easy to remember. So closed circuit is when the current will actually flow, right? So if I want to close this circuit, this will no longer be there. So we will cancel this out and we will draw the line now like this. You guys got it? So now this is going to be a closed circuit and the current can flow and the bulb will start glowing here. This is the symbol for bulb. There are other different symbols which you can learn. So this is not the only symbol for a bulb. Okay guys. So this is known as a circuit diagram, which is a simplified diagram of the circuit, because every time you don't want to draw this actual thing, right, with the bulb and the batteries, you will draw a simplified diagram like this. Can all of you see? And very good. I see some of you are writing the closed path through which electricity can flow is called an electric circuit. Excellent guys. So this whole setup, or the closed path through which electricity flows, is called the electric circuit. This entire setup here, right? So this entire setup, which contains the cells, the wires, cells basically means potential difference, the wires, the conductors through which electricity can flow, the switch, the bulb, this entire setup is known as an electric circuit. Okay, clear guys? So, and this is a circuit diagram. You must practice the circuit diagrams, draw the wires, and always remember to mark the positive and negative potential in the battery, because you know the everything has the cell, it has a plus and a minus, right, potential. Okay, excellent guys. Is that clear? Now let's we didn't talk about a very important thing, which is going to be what is the direction of the flow of current. So I told you we'll be coming to that, right guys, because we know that the electrons are flowing in the wire, right? Did we discuss about that? So because we said that when this circuit is on, right, so when, let's say, this switch is in the on position, so let's say we cancel this and the switch becomes here in this on position. So when we switch it on here, right, then these electrons are going to flow, right? So the electrons will start flowing in the wire. Okay, so one very important thing is, guys, what is the direction of flow of electrons? Excellent. I see Nipun is already given an answer. Raja Mukherjee is trying an answer. Excellent guys. So guys, think, what do you think will be the answer here? So when electrons are flowing in the wire, right, what is the direction of flow of electrons? Because you know that when you connect this, the electrons will be flowing, right? So electrons are flowing, but what is the direction of flow? So I'll give you two options here. So you know that the cell has, you know, the positive and negative, right? So it has a positive terminal and a negative terminal, right? This battery. So can you see here guys, this is the positive side. Can you see on the circuit diagram? I'm marking this in pink here on the circuit, and the negative here, can you see in yellow, right? So this overall, there's a plus minus, right? So now the question is, are the electrons flowing from positive to negative or negative to positive? Very, very important thing to know. Okay, what is the direction of flow of electron? So how will you remember this? Let me share a very simple technique, a very simple tip for you. You know that the electrons are negatively charged particles, right guys? The electrons are negatively charged particles. Negatively charged particles. And what direction do negatively charged particles move? Because the negatively charged particles will be attracted towards the positive end. Okay, so they are going to come out of the battery from the negative end, and they will be attracted towards the positive end. Okay, so electrons, please note, very, very important to know this. Electrons, they flow from negative to positive, right? And how will you remember that? Electrons are negatively charged, so they will be attracted towards the positive end. That's a rough way of remembering. So electrons flow from the negative potential to the positive potential. Very, very important to know. So electrons, let's write that. Electrons flow from negative to positive. So let's write that, flow from negative terminal, right? So from negative to positive. And guys, do you know what is this current known as? So we know it's called electric current. So the flow of electrons, the direction of flow of electrons, this is called electronic current. Very important term, electronic current. Okay. So if we mark it in the, let's mark it in the circuit here, right? So let's mark our electronic current. What direction it's going to follow in the circuit? It's going to be this way, right? So the electrons are flowing from negative to positive. So electron flow, if I'm marking, please note, I'm writing the E over there, right? Electrons are going to flow from negative to positive, of course, when the switch is closed, right? So let's say the switch is closed here, right? Let's cancel that in red here, right? So let's say the switch is closed. So the electrons are going to flow from negative to positive, right? Does everyone agree? This is known as E, represents the electronic current, okay? But now there's one very interesting thing. Guys, do you know there's another term, right? To make things confusing, there are a lot of terms in electricity. There's a thing called conventional current, okay? So actually, when you see the circuit diagrams, guys, the electronic current is usually not marked, okay? Very important. So I'm going to erase this electronic current, or later we'll erase that later, right? So actually you'll find the current shown in the circuit, right? The conventional current is marked this way. So when they mark the current, it's from positive to negative. And do you guys know why, right? So the current in the circuit, which I'm marking with the pink color and I symbol, right? I represents the conventional current. So I is conventional current, which is from positive to negative. Positive to negative. Okay, can you see in the circuit I've marked it for you, right? Okay, I think my head is hiding the circuit, so I'm trying to dodge here, right? And guys, the electronic current, which is marked with the E, is from negative to positive. So they're opposite. Okay. So question is, why this confusion? Which one should we use, guys? Do you guys know? So electronic current is from negative to positive. Okay. So please remember that it is the conventional current that is marked. It is conventional current that is important, and it is usually marked from positive to negative. So why this whole confusion, right? The fact is because electric current was discovered before electricity, before the electrons. So electricity was discovered before the discovery of electrons. And when they discovered electricity, the scientists assumed that it is the positive charges that are flowing. Okay, so they took that as the convention, just like they took the convention of, you know, a positive and negative charge for the glass rod and for the silk cloth and the ebonite, right? Those are all conventions. So same way that they made up, right? So same way they said, okay, the electricity we are going to mark just like water flows from high potential to low potential. We are going to mark electricity in the same way from high to low potential, so positive to negative, because electricity was discovered before electrons. But when they discovered the electrons, they said, oops, it's actually wrong. The charged particles that are flowing in the wire are not positively charged particles. They are not the protons, because protons are tightly bound in the nucleus. It is really the light electrons that are moving in the wire. Okay, so they said, okay, that was wrong, but we are not going to change all the textbooks. We are not going to change all the scientific papers. We are going to consider that as conventional current, because it is convenient to think electricity flowing from high potential to low potential. Okay, but the reality, guys, is it is actually opposite the electrons. But don't confuse whenever you have to mark. So I'm going to erase the electrons in that electron direction in that circuit, because whenever we mark it, guys, we always mark, unless really asked, we mark the conventional direction. So guys, you can see I've erased the electrons. Okay, so please remember this very important concept. Conventional current is what is often marked, and it's from positive potential or high potential to low potential, and the electronic current is opposite. Clear, guys? So very, very important thing, right? And it is battery, the cells, which is providing the, so let's revise that. So what is the cells providing? The battery is providing the potential difference. So this is the electric potential, right? Which is causing the electrons to flow, or we think it, the conventional current to flow from positive to negative, and that is why the bulb glows. Clear, guys? And the wires are good conductors, you know, because wires are full of free electrons. So we'll not do that detail in today's class, but wires are good conductors because they're full of electrons that can easily move in the wire. And who's pushing them? The electric potential, the battery. Clear, guys? And so always remember to mark the conventional direction of current. Excellent, excellent. So guys, I have one interesting homework question for you. What is the work done in moving 3 coulombs of charge across a potential difference of 6 volts? So you need to calculate the work done in moving 3 coulombs of charge across a potential difference of 6 volts. Is it 2 joules, 2 amperes, 18 joules, or 18 ampere? And guys, do write your answers in the comments below. I look forward to reading all of your answers. And so please write it in the comments, and I will promise to reply to them as soon as possible. So guys, do write down the answers, And thanks again for joining us in this live class on electricity. Hope it was an electrifying class for you. And if you haven't subscribed to our YouTube channel, please hit the subscribe button right now and do click on the notification bell so that so that you get notified about more live classes and the videos that we upload. And guys, do check out our website because we have these awesome courses where you get to watch interactive videos, attend more live classes that I take on our website. There are quizzes and questions, and you get direct replies from me. So guys, these courses are at a special discount for a very limited time. So please do check out the courses on physics, chemistry, and we have maths also launched for class 9 and 10 for CBSE board, and we have physics ICSE class 9 for the ICSE board. Okay guys, so do check it out and try this homework question. And also you should find out that guys, we talked about, remember I told about the cell, right? So do check out the cell, right? It is 1.5 volts. And do you know how much electric potential? So let me ask you, how much electric potential do you get at home? So what is the electric potential that you guys get at home? Do you know? So what is the voltage supply that is present at our homes? So the electric potential that we get, so the electric potential, let me spell it correctly, potential at home. Okay, so how much are you guys getting? Very good, very good. I see a lot of answers. So excellent guys. So in India, you know, the voltage is 220 or 240. So in India we write 220 volts, right? In the US, you know, it's 110 volts. Okay, so different countries, they have different voltage that you get at your home. Okay, so it depends on which country you're living in. Okay, in India it's 220 volts. In United States of America it's 110 volts. I think England, Japan, they have a different voltage. So, and yeah, of course it's a range, 220 to 240, somewhere it's written 230, but the standard value is 220 volts. So it's much higher than a cell, and that is why electricity is dangerous, because high potential can cause high current. You can get a very bad shock. So you should always be careful when handling electrical equipment, wearing your wearing shoes or slippers, right? So rubber slippers, rubber shoes, okay, and never to touch switches with wet hands, because there is high voltage coming in at the home. Okay, so great guys, it was a great session. I really enjoyed it. You were really interactive. I'll not give the answer of this question because I want you to put it in the comments below. And do keep checking our website and our YouTube channel. And guys, if you haven't hit the like button, please hit it right now and do share it out with all your friends and your family. And thanks for joining us. So hopefully we'll have another class on Wednesday, because you know the Calcutta, the weather right now is bad, but I think on Wednesday we'll be having a class, a maths class, I think. So guys, do check it out. It's at 8 p.m. So some of you are asking, when is the next live class? This Wednesday at 8 p.m. And I think I'll be taking a maths class on Wednesday. All right, guys, take care, everyone. This is Sandeep Manocha signing off, and hope you enjoyed this class on electricity. Take care, pray for your good health. I really pray for everyone's good health. And guys, keep studying, keep learning, and take care of yourself. Bye-bye.